Hello, welcome to the hydraulics class. In this module, you can see the problems on venturimeters. A horizontal venturimeter with inlet and throat diameters 300 mm and 150 mm respectively, used to measure the flow of water. The reading of the differential manometer to the inlet and throat is 200 mm of mercury. Determine the rate of flow. The CD equals to 0.98. The solution, that is the given data will be given, that is d1 equals to 300 mm 0.3 meter, d2 equals to 200 mm 0.2 meter, x the reading of the manometer 200 mm, that is 0.2 meter, cd equals to 0.98. First of all, you have to determine the cross section area at the inlet and outlet, that is a cross section area at the inlet A1 equals to pi by 4 d square, that d1 square, that is 0.3 square, that is 0.0706 meter square. Cross section area at the outlet A2 equals to pi by 4 d2 square, and the 0.0314 meter square. Then actual discharge equals to C A1 A2 under root of A1 square minus A2 square into under root of 2GH, where H is the head of the water, that is x into Sg minus Sw. Sg equals to 13.6 and the water is flowing in the pipe, that is specific gravity of water is 1, that is 2.52 meters. Then Q actual equals to, you can substitute the values in the equation, that is C equals to CD, that is C A1 A2 A1 under root of A1 square minus A2 square into under root of 2GH. Then Q actual equals to 0.242 meter cube per second. That is the next problem, that is an oil of specific gravity 0.8 is flowing through the venturimeter having the inlet diameter 200 mm and throat diameter 100 mm. The oil mercury differential manometer shows the reading of 250 mm and calculate the discharge of all oil through the horizontal venturimeter. Take CD equals to 0.98. Here d1 equals to the 0.2 meter, d2 equals to 0.1 meter, x reading of the manometer is 250, that is 0.25 meter, and CD equals to 0.98, and specific gravity of oil is 0.8, that is. Then you can have, that is first of all you have to find out the cross section area, that is A1 A2, that is 0.0314 meter square and 0.00785 meter square. That actual discharge equals to C A1 A2 under root of A1 square minus A2 square into under root of 2GH. This gives the 4 meters of oil. 4 meters of oil. You have to convert, that is H is equals to X into Sg by S naught minus 1. That is a 0.2 pi. Sg equals to 13.6 and oil specific gravity of oil is 0.8 minus 1, that is, it equals to 4 meters of oil. Then substitute the values in Q actual, then we can get the 71.31 into 10 raised to minus 3 meter cube per second, or you can convert into the liters by multiplying 1000, that is 71.31 liters per second. Then third problem, that is horizontal venturimeter with inlet diameter is 200 mm and throat diameter is 100 mm is used to measure the flow of oil of specific gravity 0.8 and discharge of oil through the venturimeter is 60 liters per second. Find the reading of the oil mercury differential manometer. Take CD equals to 0.98. In this problem we are going to determine the x, that is, so you have to find out the h from the actual discharge. All the given data, that is the d1 is equals to 0.2, d2 equals to 0.2, d1 is 0.1, q is given, that is 60 liters per second, that you have to convert into the meter cube per second, that is 60 into 10 raised to minus 3. CD equals to 0.98. Specific gravity of oil is 0.8. Then A1 equals A1 and A2, that is cross section area at the section 1 and 2. You have to determine actual discharge equals to C A1 A2 under root of A1 square minus A2 square into under root of 2GH. So substitute, then you are getting the h small h equals to 2.9 meters of oil, where h is equals to x into bracket sg divided by s naught minus 1 then. So manometer reading x equals to 0.181 meters, or you can say that is 181 mm, that is. The next problem, that is an oil of specific gravity 0.9 is flowing through a venturimeter having a diameter 200 mm and throat diameter 100 mm. Oil mercury differential manometer shows the reading of 200 mm. Calculate the discharge of oil through the horizontal venturimeter. CD equals to 0.98. D1 equals to 0.2 meter, D2 is equals to 0.1 meter, X equals to 200 mm, that is 0.2 meter, CD equals to 0.98, and S naught, the specific rate of oil is 0.9. Cross section area to find out, that is A1 and A2, that is 0.0314 meter square and 0.00785 meter square. H is equals to S into your under root into bracket SG divided by S naught minus 1. So we are getting 2.82 meters of oil. Then substitute the values in Q actual equals to C A1 A2 divided by A1 square minus A2 square into under root of 2GH. So you have to calculate the discharge, the Q actual, that is 0.059 meter cube per second, or you can say that is 59 liters per second. In last problem, that is a horizontal venturimeter with inlet and the throat diameter is 300 mm and 150 mm respectively, is used to measure the flow of water. The reading of differential manometer connected inlet to the throat is 100 mm of mercury. Determine the rate of flow. CD equals to 0.98. So D1 equals to 0.3 meter, D2 equals to 0.15 meter, X equals to 0.1, CD equals to 0.98. First you have to find out the A1 and A2, that is 0.0706 meter square and 0.0176 meter square. Then actual discharge equals to C A1 A2 under root of A1 square minus A2 square into under root of 2GH. So SG minus SW. So that is 1.6 meters of water. Then Q actual equals to 0.0885 meter cube per second, or you can say that is 88.55 liters per second. Then problems on orifice meter, that is orifice meter is similar to the venturimeter, then same formula will be using, that is an orifice meter with orifice diameter is 100 mm and is inserted in a pipe 200 mm diameter, and pressure gauge fitted at the upstream and downstream of the orifice meter gives the reading 19.62 into 10 raised to 4 Newton per meter square and 9.81 into 10 raised to 4 Newton per meter square respectively. Then coefficient of discharge for a meter is given as 0.6. Then find the discharge of water through the pipe. The first of all, he has given that is upstream, that is a pressure at 1 and 2, that is a P1 equals to 19.62 into 10 raised to 4 Newton per meter square, and P2 equals to 9.81 into 10 raised to 4 Newton per meter square, CD equals to 0.6, and D1 equals to 0.2, D2 equals to 0.1 meter. Then first of all, you have to find out the difference of pressure head H equals to P1 minus P2 divided by W, that is 19.62 into 10 raised to 4 minus 9.81 into 10 raised to 4, or you can say that is 9.81 into 10 raised to 3 Newton per meter cube, that is a 10 meters, it is. Then discharge, actual discharge Q actual equals to C A2 A1 divided under root of A1 square minus A2 square into under root of 2GH, where C is the coefficient of discharge of the meter, that is 0.6. 0.6, then you will find the discharge, actual discharge equals to 0.06813 meter cube per second, or 68.13 liters per second. The last problem of this chapter, that is an orifice meter with orifice diameter is 150 mm is inserted in a pipe diameter of 300 mm diameter, and pressure difference measured by the mercury oil differential manometer on the two sides of the orifice meter gives a reading of 500 mm of mercury. Find the rate of flow. The specific gravity is 0.9 when the coefficient of discharge of meter is 0.64. Here the diameter of the orifice pipe will be taken as a D1 and orifice diameter is taken as a D2, 0.3 meter and 0.15 meter, and oil mercury manometer different reading is given, that is 500 mm, that is 0.5 meter, CD equals to 0.64, and S naught, the specific gravity of oil, is 0.9. First of all, you have to find out the cross section area A1, A2, and difference pressure head, that is H equals to X in under bracket under root of sorry into bracket Sg by S naught minus 1. So the 7.055 meters of oil. Then actual discharge equals to CA1 A2 under divided by the root of A1 square minus A2 square into under root of 2GH. So we are getting it is 0.1368 meter cube per second, or you can say that is 136.81 liters per second.